Good afternoon, everyone. I am so excited to be here today, and I would like to thank the committee organizer for this opportunity. For the limited time given, I will focus on the main ideas of my representation that talks about generalizing of elliptic zeta functions to any subgroup of SL2 of Z. So let's dive right in. We'll start by the main concept that's related to the elliptic zeta function, and start by introducing the lattice lambda. It is a subset of C, and it is a subset of C with Z basis, such that it could be written as a linear combination of omega-1 and omega-2, such that the imaginary part of it is quotient of omega-2, quotient by omega-1 greater than 0. And this is a part of the domain of elliptic zeta function. A quasi-periodic function. Quasi-periodic function, it is a meromorphic function relative to lambda, such that for every omega in lambda, in the lattice lambda, we have the subtraction of f of z plus omega, and f of z gives us a constant h of omega in C for all z in C, such that this constant h of omega, it is z linear in the following sense. Now we will talk about the case of modular subgroup for the elliptic zeta functions. For your information, this function introduced by Brady in 1960s. And since that, no one works on these functions till like 2019, I started figure out more about this elliptic zeta function. So elliptic zeta functions that's defined from it is domain C cross L. L, it is the set of all lattices in C, okay, and it is codomain C hat. It is a meromorphic functions. It is a quasi-periodic functions as I defined before, and it is homogeneous of weight M, and it is quasi-periods are meromorphic functions on the upper half plane H. A basic example on elliptic zeta function, it is diverse class zeta function that defined by the following formula. The derivative of elliptic zeta functions gives us minus p, which is a periodic function with 0 quasi-periodic functions. And it is homogeneous of weight -1 in the following senses. Now I will talk about the quasi-periods of elliptic zeta function zeta. It is defined by eta1 and eta2. It is this elliptic zeta, these quasi-periods very important because when we take the quotient of these quasi-periods, gives us some a new relation or defined as a new function. That functions compute the action of SL2 of Z on H in the following sense. And introduce us a function that is a meromorphic function, which is defined by equivariant function. Now we will go to how to generalize this elliptic zeta function to any finite modular subgroup of SL2 of Z. Motivation. So I start by defining this M. This M, it is the set of all ordered pairs omega-1 and omega-2. And gamma, it is an element of SL2 of Z, as you see. We define the action of gamma on this ordered pair as follows. So now I introduce omega gamma, which is defined by the quotient of M by gamma. It is denoted by the set of all classes omega-1 and omega-2. So here, in my case, if omega equal SL2 of Z, this equivalence class gives us lambda, which is I defined before. And if it is gamma, if gamma it is subgroup of SL2 of Z, now we could generalize this function as follows. So gamma elliptic zeta function now, it is generalized by replacing the lattice lambda by omega gamma, where omega gamma, as I mentioned before, it is the quotient of M by gamma. So this elliptic zeta function, it is now generalized and satisfy the same condition for the elliptic zeta function with respect to SL2 of Z, in a sense that it is meromorphic and it is homogeneous of weight K, and it is a quasi-periodic functions, and it is quasi-periods H1, H2 are meromorphic in H. So it is fully satisfies the whole conditions that's defined by Brady. Now, the structure of this function, the gamma elliptic zeta functions, could be written in, as a linear combination of linear functions z and elliptic zeta functions with coefficient phi and psi. So any elliptic zeta function can be written in this formula, such that zeta and z are elliptic zeta functions. And here I summarized the triple correspondence between these three notions. This is elliptic zeta functions. When I take the quotient of its quasi-periods, I get equivalent function, which is compute the action on SL2 of z. And if I took the coefficients that I mentioned before, this phi and psi, when I took this quotient, psi over phi, introduced me a modular function of weight 2. And here also I close the map from a modular function of weight 2 to equivalent function by this formula, which is by multiplying f by by the matrix and tau, where on tau it is the quasi-periods of the identity function and the elliptic zeta function. Thank you for your attention.